Hello everyone, and welcome to the video on how to add subtract radicals. And here we're going to talk about multiplying radicals, not like what we talked in a previous video, but this one's going to be more of a distribution over addition and subtraction, a little bit of foiling and stuff like that. So let's go ahead and talk about how to add and subtract radicals. To do this, we have to add apples to apples and oranges to oranges. So the first condition that has to be met is that we have to have the same index. The same index to the radical, that is, we add square roots to square roots, cubed roots to cubed roots, fourth roots to fourth roots, and so forth. And then the second condition is that we have to have the same radicand. So for example, if we want to take the square root of 3 and add the square root of 3, note that since we have the same radical with the same index and the same radicand, we just get 2 square roots of 3. If I want to add the square root of 3 plus the fourth root of 3, notice that even though we have the same radicand, I have a square root and a fourth root, and technically we cannot do this, so it's just the square root of 3 plus the fourth root of 3. And if I have something like the square root of 3 plus 4 square roots of 5, even though I have the same index, I have a different radicand, so this is just the square root of 3 plus the 4 square roots of 5. So no matter if it's add or subtract. Okay, so let's take a look at the cubed root of 17 plus 5 cubed root of 17. And again, since our radical is the same index, the same radicand, I have a grand total of 6 cubed roots of 17. Okay. If I have 7 cubed root of 5z minus 12 cubed root of 5z, notice I have a grand total of negative 5 cubed roots of 5z. Okay, and again, if we have 3 square root of 2 minus 5 square root of 2x. Again, even though we have the same square root, we do have different radicands, so we just get 3 root 2 minus 5 root 2x. Okay. Now we saw before that the nth root of a times the nth root of b is equal to the nth root of AB. All right, so for example, if we have the cubed root of 5 and we want to multiply the cubed root of 2, then we get the cubed root of 5 times 2, which is the cubed root of 10, and we're all done. Okay, so let's just take a look at another one. We already talked about this in a previous video, so the rule says here that we have to have the same index to perform the product. So again, if you have the fourth root of 5 and you want to multiply the square root of 7, note we cannot do this product because the index to the radicals are different. Okay, so we cannot perform that. So let's take a look at the example, the square root of 5 times 2 plus the square root of 15. So notice here, if I distribute this root 5 across the addition, I get 2 root 5. And again, if I bring it over to here, then I get root 5 times root 15. And let's just note I get 2 root 5 plus the square root, and notice that 15 times 5, well, let's just write it out. So 5 times 15. All right, so notice that this is 2 root 5 plus, and 5 times 15, you can go ahead and pop your calculator out, but it looks to me like we get the square root of 75. So again, using our previous video, we have to simplify this, and notice that this is 2 times the square root of 5 plus the square root. Notice that 75 is 25 times 3, so this comes out to 2 root 5 plus 5 root 3. And that will be our final answer there. Let's take a look, see at something like, well, let's take a look at 3 root 18 minus 5 root 50. Okay. So let's take a look at this one, coming back. So the question now is, can I write 18 as the product of two numbers where one of those that I could take the square root of? So notice that this will be 3, and 18 we can easily see is 9 times 2. Minus 5 times the square root of 50. So let's just note that 50 is 2 times what, 25? All right. And notice that we can take the square root of 9, and we can take the square root of 25. So I get 3 times the square root of 2 minus 5 times the square root of 2. And this is equal to 9 square roots of 2 minus 25 square roots of 2, which is a grand total of minus 16 square roots of 2. All right, so let's take a look at the square root of 2 minus 2 square root of 11 plus 6 square root of 2 plus 4 square root of 11. So again, we have to make sure that we add apples with apples and oranges to oranges. So notice that the square root of 2 and the square root of 11, we cannot combine those. But I can combine this square root of 2 with this square root of 2, and let's note that we have a grand total of 7 times the square root of 2. And I can take this square root of 11 and combine it with this square root of 11, and notice that we get 2 square roots of 11. Oops. 2 square roots of 11. Okay. So again, keeping apples with apples and oranges with oranges. Let's take a look at 3 cubed root of 2 plus 8 square root of 5 plus 2 cubed root of 54 plus the square root of 125. All right, so let's just see if we can't do some cleanup work here and combine similar radicals here. So not much to do with this first term, so I'm just going to bring it down. 3 cubed root of 2 plus, not much to do with the square root of 5. So I get 8 square roots of 5 plus 2 cubed roots. So the question now is, can I rewrite 54 as a product of two numbers where I have a perfect cube? So again, if you come over here, 54, so 2, I think that's 27. And let's just note that 27, the cubed root of 27 is 3. So boom, we got that one pretty quick. So 2 times 27 plus, and now the question is can we do the same thing with 125? So let's just note that 125 as a perfect square, that's going to be 25 times 5. So again, the first two terms, there's nothing to do. So 3 cubed roots of 2 plus 8 square roots of 5 plus 2. Notice that this 27 comes out of the cubed root as a 3. So I get a cubed root of 2 plus, and notice that this 5 comes out of the square root as a 5. So we're left with a square root of 5. So I get 3 cubed root of 2 plus 8 square root of 5 plus 6 cubed root of 2 plus 5 square root of 5. So again, we notice that I could take this, combine it with this, for a grand total of 9 cube roots of 2. And I can take 8 square roots of 5 and 5 square roots of 5 for a grand total of plus, let's see, 8 and 5, 13 times the square root of 5. Okay. All right, so again, just to take a look at a couple of adding ones. So let's take a look, just add a couple of more multiplications. So square root of 2x times the square root of 6x minus 3 root x. So again, if I distribute this across, we get the square root of 2x, square root of 6x, minus square root of 2x, 3 square root of x. Okay. So I can bring these inside, so I get the square root. So 2 times 6 is 12. X times x is x squared. Minus, so I got my 3 right here. I'll just bring that out front. Square root, so 2, nothing to combine there. And x times x gives me an x squared. So note that 12 is 4 times 3, so I get the square root of 4 times 3 times x squared minus 3 times the square root of 2x squared. So notice this 4 comes out as a 2. Our x squared comes out as an x, so I get the square root of 3 minus 3. This x squared comes out as an x times the square root of 2, and that pretty much clears it up for us. All right. So, I don't know. They all have a sense of tediousness to them, but oh well, gives it a little more fun, a little flavor. So 4 cubed root of 3 times 9 cubed root of 8. 9 cubed root of 9 plus 7 cubed root of 7. So again, we'll go ahead and distribute this. So I get 4. 4 times 9 is 36. So I get the cubed root. And notice that these are the same, so I get 27. Plus 4 times 7 is 28. Cubed root, and then 3 times 7 is 21. So notice the 27 can come out, so I get 3 times 36 plus 28, and notice there's nothing to do with the 21, which is only 7 times 3, so we get our 21. So here we get 6 times 3 is 18, 108 plus 28 cubed root of 21, and that closes us up. All right, so our last example again, just a little FOIL method here. Take a look at the cubed root of 2 minus 6 times the cubed root of 4 plus 3. All right, get a little FOIL action in. So cubed root of 2 times the cubed root of 4. So we get the cubed root of 2. Let's just write it out. So the cubed root of 2, cubed root of 4. So that takes care of that one. So then we take plus 3 cubed root of 2. And then we go minus 6 cubed root of 4. And then minus 18. So this becomes the cubed root of 4 times 2 is 8. Plus 3 cubed root of 2, nothing to do there. 6 cubed root of 4 minus 18. Notice I cannot do anything with those two. Even though they have the same index, they do not have the same radicand. So notice the cubed root of 8 is 2 plus 3 cubed root of 2 minus 6 cubed root of 4 minus 18. So at the end of the day, we have 3 cubed root of 2 minus 6 cubed root of 4, and then 2 minus 18 is minus 16. Okay, so that covers our section 10.4 video. I hope that helps you out, and if you have any muddy points or any questions regarding this video, Be sure to share those with me in our muddy points. Outside of that, I will see you in class. Thanks a lot. Bye.